So as you see, this is my Rhino screen, Grasshopper screen, and this is a Boolean toggle. Let me delete this first. So what is a Boolean toggle and where I can find it? Let's start with where I can find it. So you can double click and say toggle, and you can see the Boolean toggle, or you can go to prompts, under input, you can grab a Boolean toggle. Boolean toggle is a component which has information related to being false or true. If you double click to this black area, you can switch it false to true, and so on and so forth. This we'll be using this in many different kind of cases to show you what they are being used for. However, I wanted to show you how the computer understands this. This basically means if I grab a panel, if I connect this to here, it's false, right? And if I copy this and paste underneath, what I'll be seeing is true. So what we see here is basically true and false, but it also can be described with numbers or numeric values. So when we connect this false value to a number, maybe I can make this a bit smaller and then connect it over here, okay, and then pull out another panel, what I'll be seeing is this is going to be 0, right? And if I do the same thing for this one, Control C, Control V to copy this and paste, what I'm seeing is basically this is true. True meaning what? Okay, so in any kind of operations in which we need these kind of booleans like trues or falses, we can always use numeric values for to replace them as well. But are they really limited to zeros and ones? They're not really. So if I take this aside, group this, and take this aside, if I do the other way around, so if I connect a slider, let's say 0, and then if I grab a panel, and then if I put that panel in, I'll be seeing the same value. But if I convert this panel, or if I convert this number into a Boolean, if I go under geometry, under primitive, if I grab a Boolean component, which is an empty one, and if I copy and paste this panel, what I'll see is it's false, right? And if I do the same, copying this and pasting it, if I put any number that is larger or different than 0, you'll see that it turns into true. Even like when we test, let's test this with minimum like -5, and if we take this to -5, you see it still gets sort of a true value, because when we change this something from 0, like change it to something from 0, it will always be true. This, as you see, this is my Boolean basics that I just showed you. And in this one, what I'll be talking about is these two components. If I undergo set under sequence, what we are going to see, what we are under list, what we are going to see is this patch, and the other is Cull Pattern. And Cull Pattern is under sequence, okay? So what these two components doing? When we supply a list, they will ask us a dispatch pattern. In this case, it has true, false, and this has false, false, true, true, and this is the list to call. Basically, what this does, it's based on the true and false values. It puts the true labeled values onto output list A and false labeled outputs onto list B, and this will call all the items with all the information in the list if they are labeled as false, and shows us only the true. So this may not ring a bell in your mind, so let me create an example. So let's create some random values, like let's create in between 0 and 1, but it's too small, so let me create a range here. So maybe I don't take this slide, so I will have a bit more space. So between, let's say, 0 to 10, and let's have this range, let's have 15 numbers, and let's see what we are doing if we connect. So if I call a panel here and connect this to the panel, you see we are having these values, and these values are some values. You can round them if you want to see them a bit clearer maybe. So this is my nearest values, and I put these values in. So what is this? Is basically this is my information, right? This is my normal information. And what I'll be seeing if I connect the panel to the falses for list A. List A going to dispatch or it's going to separate the values that are labeled as true. So this is my true values, because now what it does, it basically take this, and this is my true value, false value, true value, false value, true value, false value, to so and so forth. So if I grab my list B here and put it in, what I'm seeing is, you see, false, 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 so on and so forth. So basically, this is my component called dispatch. It dispatches all the values based on the dispatch pattern that I supply. But it doesn't have to be, true, true, false. If you create a merge component, and if you say, I would be creating toggles, let's say 3 times, and yes. This time, if I connect this to my dispatch pattern, what I'll be seeing here is, oops, wrong direction. So what it does, basically, it will take, you see, false, false, true, and true goes to here. False, false, true, and true goes to here. False, false, true, and true goes to here, and so on and so forth. So basically, this is the one that we are using as we go with the dispatch. So if I take the same example and use it below, so if I copy paste this, and if I use this value, again copying and pasting the round, oops, not Control X, Control C, and Control V. So let's say this is my value, and if I pull out a panel, connect this panel to here for my 14 values, and if I connect my another panel here to the output of my list Cull pattern, you see it takes out all the information based on its pattern, but this pattern this time is not true false. It's false false true true. So false false, they're gone, true true, they stay. False false, they're gone, true true, they stay, and so on and so forth. Obviously what we can do here, we can connect 2 Boolean toggles, not this one, and we can say true and false. You see, this time true, false, it only keeps the true values as we speak. As you know, this is dispatch and Cull pattern. So what I'll be doing now, I know this is all in Grasshopper now, but I'll be talking about some things in geometric examples just in the next video, okay? So let's say we again create some numbers, numeric values. Let's say this time, like, we create a range, or if you create sort of if I go to math, maybe I can create a domain. So that domain can be between 0 to 100 this time, or not 100, again, maybe 10 this time, because we'll be dealing something, we want to have sort of a controlled data here, maybe 15. I mean, it's completely up to you actually. So we can put this range, or we can put sort of yeah, let's keep this range in, and you can put round as well if you want to. So let's generate like 8 values here, okay? And remember, like, you remember that, like, if you play with the seed value of this guy with random, we are going to change the value, but let's leave it as it is now. So what I wanted to do is basically, if I want to dispatch these values, if they are like based on the relationship with a number, like let's say number, I don't know, 7. So if I go to math and under operators, if I grab, like, let's say larger than. So what this component does, it basically takes 2 inputs, the first number to test and number to test against. So if we are going to test these values against 7, what I'll be seeing as output is basically true, false, false, true, false, false. And these are correlated with one another, because 11 is larger than 7, that's why it's true. 7 is larger than 6 point blah blah, that's why it's false. Or 6 is smaller than 7, that's why it's false. 2 is smaller than 7, that's why it's false as well, and so on and so forth. And by the way, you can use equal to as well. So if we have a round value here, let's say, if we connect a round value, and if we have some values related to, oops, I connected it to wrong direction. I connect this to here, this to here, and this to here. So if you are looking into this component's outputs, let me see with this further, and what we see here is larger than if it's, but what happens if it's 7? So if we connect this, then it will turn into true, because what this does is larger than or equal to 7, and so on and so forth. And what we can do if we use the same information for culling or dispatching, what we'll be doing, basically, you see, true, true, true. So we take this number and create a relationship with number 7, and that relationship might help us to cull. So I put this back, to cull information, cull these values based on this. So what we are going to see here, if we take a look at it with sort of like, from the same point of view, if I grab a panel here, what I'll be seeing is, I'll be seeing only the values are larger or equal to 7. And if I change this, you see, I am changing the information based on this. So what I do is basically create this relationship with a set of numbers, and I want to extract the ones that are larger than 6 this time, and that's why I created this larger than sort of equation here, and then I take the information, trues and falses, and feed my call patterns, calling pattern, and then I have it as follows. And what I can do, if I use dispatch for this, I'll be seeing the same output. If I put the dispatch in and putting this guy here, what I'll be seeing is, I'll be seeing two lists. List A is going to be the ones that are larger than 6 or equal to 6, and the B list is going to be the ones that are smaller than the 7 or 6 in this case. So I can group this guys, and group the rest of the guys.
Hey everyone, if you want to access the exercise files, please click the link in the description to access our Skool community.
So this is my Rhino screen, as you see. Let's create that surface here. And I go to Rhino surface starting from 0.0, put it over here. And if I put this surface in, what I need to do is I need to put a surface. So set one surface, and this is my surface here. And to create some information on this surface, or to create some geometry on this surface, rather than this time creating a grid, this time let's populate geometry within this boundary, let's say. So count, let's say 150 points, and seed, as you might remember, is changing the randomness of this points locations. You can see that, and the points, if we have sort of a pre-existing point, in this case we don't have them. So these are the boundary of our surface. But how I can create sort of an attractive point that's only moving in this? To proceed with that, I'll be using a component called evaluate surface. What evaluate surface does, if I can see it, what it does with a given surface and a point, it gives us the point on that surface, normal vector of that surface, u direction, v direction, and a frame at uv value on that surface. So if you want a point that moves on this surface only, limited by this surface only, there are a bunch of ways to do that, like using vectors, points, so on and so forth, but we'll be using this time something super simple called MD slider. MD slider is a slider in which you have two values in X and Y, and if you double click to that, you can change this to 0 to 100 and Y to 100, let's say. And if you say okay, we are able to, oops, we couldn't change it to, yeah, now we are able to change it now. You see they're ranging between 0 and 100. And if I connect this to my point as if they are my coordinates, you see my point is moving, but it's moving super small in a super small range because my domain is super small for this surface. And if you, you obviously can double click here and then change the domain based on the size of the surface, such as the length and width. However, that won't be a super clear solution. If we want to limit this point specifically and strictly in this surface, we can do some trick. If we right click to this and say reparameterize, and if we do this again, what we are seeing now, obviously we are not able to see the point because the point is gone to somewhere. Because if you remember, we changed this value. So if I double click to this and make it 0 to 1 again, 0 to 1 again, and now I can see a point that is moving in, right? And this is why this happens, because when we right click and reparameterize, we set the UV values of this surface between, not set, but remap those values between 0 and 1, okay? Before we don't know, but now it's 0 and 1. That's why we can create this attractive point here. So I can group this, but to maybe preview it better, if I go to display under preview dot display, maybe I can create a point here, preview this off, create a swatch, maybe a white point here. The size can be, I don't know, let's say 250 maybe. So maybe even larger than that. So we have our point here, okay? And this point is basically, this is the visualization of it. So we can group these two both and repaint them or recolor them with white. And yeah, so I can put a scribble and then say tractor point, tractor. And now what I'll be doing is I'll be preparing and creating distances between my points and my attractive point. Maybe I can plug them right this way. And if I grab a panel here, what I'll be seeing is basically some values. So we can round these values, okay? And what I want to do is to revisit what we've done in the previous playlist. Let's put all these distances on the points that we are having. So if I put this like preview off, and maybe if I preview these points in a bit better way, preview them off, color, maybe we can say, I don't know, what we can say is, we can say create a swatch here, say this time black size is 100, because we want to differentiate the distance between, maybe it's too small, differentiate the size between our tractor and the random point, right? So if we are also group this, just to make sure, group this, okay, and what we see is some value. So if I grab a panel now, I probably get rid of all the decimals, which might be a good thing. But let's put all this information underneath all these points. So how I can create that? What I will be doing is I'll grab a tag 3D, as you remember, and tag 3D is going to be put on to this locations. I mean, obviously XY, but this time it directly takes these points as an input for the XY planes. So I can put this distances as my text and the size, like let's say 150, and see how big it is. So it's not that big, but one thing we can do is we can maybe put a concatenate, and this might be our first thing, could be D, and we put an enter, and then we put this guy here, and give them some space, give them some space as well. So what we are doing here is basically putting this text in, and if you put a point, that might be helpful. Or what we can say, distance, and if you justification, you just top center maybe. We know each point's distance, but that's too much to have. So why don't we have something as such? We have a bit better idea. Top center maybe, top left maybe. No, top center looks fine, but our points are a bit large, so maybe we can, yeah, have them as such. And or if you don't want this, just you can just put the text here. Okay, it's completely up to you. We can put a swatch. Maybe we can just write these values in, well, like really red, you know. So what this does is basically, as you see, when I move my point on and off, you see, it's basically changing the values. Jump back into this guy here. And obviously, like we can group all this and so on and so forth. So one thing now we are going to do is basically defining a distance. So let's say 8,000. So what we are going to do is, if we are going to say, okay, if this point is close to us more than, or if it's closer than 8,000, let's create a geometry. I don't know, let's create a geometry. Otherwise, let's create another geometry. So how I can do that? I go to math, and under the math, I'll grab some component called larger than. And this is the test against value that we are going to have. And the nearest value is the one that we are going to use to compare 8,000. And if I grab a dispatch, this is going to be my, like the ones that are larger than 8,000, or the true false value is going to be my dispatch pattern, and my population is going to be my list, right? So what I can do here, you see larger, if it's larger than 8,000, it's going to be called list A. What I can type here, list A, or I can create a point output that creates the larger point. So for that one, maybe I preview this off. Okay. So what I see now is basically the points that they are only visible if they are far away or further than 8,000, right? Do you see this here? And when I move my attractor point, it also changes, you know, you see. And what I can do here is I can say, okay, create, let's say, maybe I can preview off the distances for now. And these values really, like, maybe diminish the size of those just to make sure. What we can say, okay, let's create circles on this one with a size of 200 on these points, maybe larger than that. Okay, and we can say group, pull a scribble, and then say larger, or the distances, yeah, larger distance goes to circle, and add this to group. And if we do the same thing here, copy and paste this, and this time let's say we want to create I don't know, like a hexagon or a polygon. So go to curve, under primitive, grab a polygon. This is my plane. We can use the same size, and we can say segment, for instance, 4. And if I connect this to here, what I'm seeing is the ones that are close, you see, they turn into this trapezoid geometry, or hexagon or pentagon geometry, or triangles. So what I can say, larger distance goes to circle, and if I group this in, smaller distance, triangle, okay? And I can make this white. So what we are doing, maybe we can group this as well. So what we are doing is basically taking this point, and based on this relationship of distance of these points, we are creating different type of geometries all over our environment. So in this previous one, we have geometry by distance, as you remember. So what I can do also is preview this off and preview this all off. So what I can do now, I can copy this and paste it over here. And this time I'll be having the same points, but this time let's create same kind of a geometry here. Let's create rectangles, okay, on the same point. So I can create a point here and a point here. But if you remember the previous videos, in rectangles, we need to put sort of domains, right? So this domain is going to be this time between like let's say 150, okay, to 150, and negative between minus negative 150 and 150, right? So we can put this here, we can put this here. So they are tinier looking right now. So why don't we have something as such? I mean, if they overlap, they overlap. We don't care that much about the overlaps in this particular exercise. And we can copy this and paste. Larger distance, we don't need to group this now, but what we need to do is we need to create a surface to make this colorful, right? So I need to go to surface under freeform, boundary surface, and now I do have my surfaces defined here. And if I grab a preview, custom preview, connect this, and if I grab a color swatch, and this time let's say let's use some green, but it's supposed to be a bit, let's say, if I preview this off, you see, if my distance is larger than 8,000, I will have green surfaces or green boxes, green, let's say, and group this, copy this and paste this. And of course, then we can group this. And what we can make this color to, maybe, oops, if I double click to this, pulling it into, I don't know, maybe some bluish. And if I change this, smaller distance will come to blue. And if I obviously change my, like if I first, and maybe group this as well, this time red, pulling it over here, copy here, and say color by distance, maybe. I know this might be, yeah, this is sort of my thing to have kind of organized script. So if I come over here again, and if I change this, you see the ones that are close, it takes them into blue.